Procedure to find a sample standard deviation. Calculate the mean first, then construct a table. Construct a table to obtain the sum of square deviation, then apply the formula to find the standard deviation. As previously calculated, the mean for this data is equal to the sum of the scores divided by the number of scores, and the sum of the scores was 375, the number of scores 5, and the answer is 75. Now we need to get the deviation for each score. 67 minus 75, 72 minus 75, and so on and so forth until we get to 84. The last one will be 84 minus 75. 67 minus 75 is -8. 72 minus 75 is -3. 76 minus 75, 1, and so on and so forth. 84 minus 75, 9. Second column, we need to square them. -8 squared, 64. -8 times -8. -3 squared, +9. 1 squared, well, it's just 1. 1 squared is 1. And 84 minus 75, 9. 9 squared is 81. Now the sum of the deviation squared is equal to, the sum of the deviation square is equal to 156. We need to find the sample variance, which is the sum of the deviation squared divided by n minus 1. And that sum is 156 divided by 5 minus 1, which is 4. So the sample variance is equal to 39. Now the sample standard deviation will be equal to the square root of the sample variance. And square root of 39 is approximately 6.24. We have a list of 5 US residents, and we're being asked to determine the range of these ages. I mean, students might find it optional to arrange them in increasing order. And once those numbers are arranged in increasing order, the last number will be the biggest one. 54 is the maximum, and 9 is the minimum. So the range will be 54 minus 9, which is equal to 45. Now, in order to get the standard deviation, we need the mean. The mean is the sum of all scores divided by the number of scores. So for the mean, we'll take the sum of all the scores, which is 180, divided by the number of scores, which is 5. So the mean is going to be 36. Well, now we're going to list all the scores in increasing order. 45, 51, 54. Then we're going to list the different deviations from the mean. 9 minus 36 is negative 27. 21 minus 36 is negative 15. 45 minus 36 is going to be 9. 51 minus 36 is going to be 15. 54 minus 36 is going to be 18. The next step will be to square each one of them. Negative 27 squared, which is equal to 729. Negative 15 squared, 225. Positive 9 squared, which is equal to 81. Positive 15 squared, 225. And the last one is 18 squared, which is 324. The sum of squared standard deviation is equal to, when we add all these, we're going to get 1,584. Now the simple standard deviation is equal to the square root of the sum of squared deviation divided by n minus 1. That's the formula. So it's going to be the square root, and that sum is 1,584 divided by 5 minus 1, which is 4. And we get an approximation of 19.9. Now, there's a computing formula for sample standard deviation. It says that the standard deviation is equal to the square root of the sum of the squares minus the square of the sums divided by n, and the whole thing is divided by n minus 1. In order for you to find the correct answer, you need to follow the order of operation. First, we are going to look for the sum of the squares. Let's look for the sum of the squares. Sigma x squared I. In order to do so, we'll square each scores. 67 squared, 72 squared, 76 squared, 76 squared, 84 squared. And these are the different answers that we get using a TI-84 calculator. Now the sum is equal to 28,281. Number 2, we're going to look for the square of the sum. First, we're going to look for the sum, and the sum of all the scores is equal to 375. Now, the square of the sum will be 375 squared Therefore, the square of the sum is going to be equal to 140,625 Now the square of the sum divided by n will be equal to 140,625 divided by 5, which is 28,125. Now S becomes square root of the sum of the squares, which is 28,281, minus the square of the sum divided by n, which is 28,125 divided by 4. So it's going to be equal to the square root of 39, which is approximately 6.24.